Hello everyone. Now we can study next signal encoding technique, that is analog data to digital signal. So in analog data to digital signal, it's a transformation of analog data into digital signal. Okay, transforming analog data into digital signal. Actually, the process of converting analog data into digital data is known as digitization. Once analog data converted into digital data, three most common outcomes are there. This digital data can be transmitted by using NRZL. Also, the digital data can be encoded as a digital signal by using code other than NRZL. Also, the digital data can be converted into analog signal using one of the modulation techniques. Okay, so actually this analog data to digital signal encoding, it's a conversion of analog data into digital signal. Actually, analog data into digital data means it's a digitization. Once we completed this digitizations, we have three outcomes. The signal, that digital data that can be transmitted by using NRZL, or also it can be transmitted using some code other than NRZL. Also, it can be converted into some analog signal. So here, analog to digital conversion can be by using some codec form, that is by using a coder-decoder method. Here, two principal techniques are used. First one, pulse code modulation, and the second one, delta modulation. Okay, so here actually we are converting analog data into digital data by using some digitizer. Then this digital data can be transmitted by using some modulator as a signal. Okay, so this is actually happen in the digitization process. So first technique is pulse code modulation, or PCM. Okay, so this pulse code modulation is basically based on sampling theorem. And then what is sampling theorem? If we have a signal f of t is sampled at regular intervals of time and at a rate higher than that, twice the highest signal frequency, then the samples contains all the informations of the original signal. Okay, so the original signal f of t can be constructed from these samples by use of low pass filters. So actually this sampling is a process of measuring some instantaneous values of continuous time signal in a discrete form. Okay, actually this sample is a piece of data taken from the whole data. So this pulse code modulation is based on sampling theorem. Okay, if a signal is sampled or divided into some pieces of data at regular intervals, then that samples contains all the information of the original signal. Okay, this is actually sampling theorem. It is actually a process of measuring the instantaneous values of continuous time signal. Actually, these samples are the pieces of data that is taken from the whole data. So, നമ്മൾ ഇവിടെ പഠിക്കുന്നത് അനലോഗ് ഡാറ്റയിൽ നിന്ന് ഡിജിറ്റൽ സിഗ്നൽ ഒരു ഫോം ചെയ്യുന്ന പ്രോസസ്സാണ്. അനലോഗ് ഡാറ്റയിൽ നിന്ന് ഡിജിറ്റൽ ഡാറ്റ ആക്കുന്നത് ഡിജിറ്റൈസേഷൻ പ്രോസസ്സ് എന്നാണ് അതിനെ പറയുക. ആ ഡിജിറ്റൈസേഷൻ പ്രോസസ്സിൽ കിട്ടിയിരിക്കുന്ന ഡിജിറ്റൽ ഡാറ്റയെ നമുക്ക് ഒന്നുകിൽ NRZL ഉപയോഗിച്ചിട്ട് ട്രാൻസ്മിറ്റ് ചെയ്യാം, അല്ലെങ്കിൽ സം കോഡ് യൂസ് ചെയ്തിട്ട് അതർ ദാൻ NRZL യൂസ് ചെയ്തിട്ട് ചെയ്യാം, അല്ലെങ്കിൽ സം മോഡുലേഷൻ ടെക്നിക്സ് യൂസ് ചെയ്തിട്ട് ചെയ്യാം. ഓക്കെ, ഇവിടെ നമ്മൾ അനലോഗ് ഡാറ്റയെ ഡയറക്റ്റ് ഡിജിറ്റൽ സിഗ്നലിലേക്ക് കൺവേർട്ട് ചെയ്യുന്ന ഒരു പ്രോസസ്സ്. അതിന് രണ്ട് മെത്തേഡ്സ് ആണുള്ളത്. ഒന്ന് പൾസ് കോഡ് മോഡുലേഷൻ, രണ്ടാമത്തത് ഡെൽറ്റ മോഡുലേഷൻ. ഹിയർ ഫസ്റ്റ് ടെക്നിക്ക് എന്ന് പറയുന്നത് പൾസ് കോഡ് മോഡുലേഷൻ. ഇറ്റ്സ് ബേസ്ഡ് ഓൺ സാമ്പിളിംഗ് തിയറം. അതായത് നമ്മുടെ ഒറിജിനൽ കണ്ടിന്യൂസ് ടൈം സിഗ്നലിനെ ഡിസ്ക്രീറ്റ് സാമ്പിൾസ് ആക്കി മാറ്റുകയാണെങ്കിൽ ആ സാമ്പിൾസിൽ ഒറിജിനൽ സിഗ്നലിൻ്റെ എല്ലാ ഇൻഫർമേഷനും കണ്ടെയ്ൻ ചെയ്യും എന്നുള്ളതാണ് സാമ്പിളിംഗ് തിയറം കൊണ്ട് പറയുന്നത്. ഓക്കെ, Actually, this analog samples that we are sampling continuous time signal or analog signal. So these analog samples are called PAM samples. They are known as pulse amplitude modulation samples. Okay. To convert these samples to digital, each of these analog samples must be assigned a binary code. Okay. So actually this PCM starts with, you can see in this figure, PCM starts with a continuous time signal. Okay. It's a continuous amplitude signal, continuous time, continuous amplitude signal. And there will be that will be the input to the PAM sampler. Actually, what is the function of this sampler? Sampler produces samples from the analog signal. Okay. So by using the PAM sampler, what we are getting is some digital signal or discrete time continuous amplitude signal. Okay, they are known as PAM pulses. Okay, so this is the block diagram of PCM, or it is the working procedure of PCM. So first step is we are taking input as continuous time, continuous amplitude input signal. That is analog. Okay. So first that will be given to some PAM sampler for sampling process. Actually this sampler is based on sampling theorem, right? So it will produce some digital data. It's actually a discrete time continuous amplitude signal. They are known as PAM pulses. Okay. And this digital signal consists of blocks of n bits, where each n bit number is the amplitude of PCM pulse. And next process is some quantization process. Okay, so quantization process is by using some quantizer. By quantizing the PAM pulses, it is now only approximated and cannot be recovered exactly. Actually, the output of PAM sampler is PAM samples. They can be recovered correctly at the reception site, but after quantizations we are getting is PCM pulses. It is actually a discrete time, discrete amplitude signal. Okay, so they cannot be recovered completely or exactly. And the third process is, or the third step is, by using some encoder, we are encoding this PCM pulses to some digital bit stream output signal. So actually what we are doing is, we are given an analog signal to the input, PAM sampler. Then after encoder, what we are getting is a digital signal. Okay, actually that is the process behind PCM. Okay, so the PCM block diagram contains main three components. What are they? PAM sampler for sampling, and next is the quantizer for quantizing process, and the next is the encoder for encoding into a digital signal. Okay, and now we can study what are the components of a PCM encoder. So PCM block diagram, we have a sampler, PAM sampler, quantizer and encoder. So actually that three components are known as PCM encoder. Okay, sampling, quantizing, encoding, which is collectively known as PCM encoder. After sampling, what we are getting is PAM pulses. After quantizing, what we are getting is PCM pulses, and after encoding we are getting some digital stream of signal or digital bit stream signal. Okay, so here the first step is analog signal is sampled, and the second step is sampled signal is quantized, and the third one, quantized values are encoded as a stream of bits. These are the three main steps that is undergoing in PCM or pulse code modulation. Okay, Actually, what do you mean by this quantization? It is a process of mapping input values from a large set to output values in a smaller set. Actually, it's a mapping from larger set of values to smaller set of values. Okay, and the difference between the input value and its quantized value. So the input value is a larger set and the quantized value is a smaller set of bits. So it's the difference is known as quantization error, okay, or round of error. Okay, so one of the basic choices in quantization is the number of discrete quantization levels to use. So find out the number of quantization levels in a PCM, which is equal to 2 raised to n levels. Here n is the number of bits in a digital data. Okay, and how to find out the SNR ratio in a ratio for the quantizing noise in a PCM. This is the equation. SNR dB is equal to 20 log 2 raised to n plus 1.76 dB, which is equal to 6.02 n plus 1.76 dB. Here n is the number of bits used for the quantization. So by using this n number of bits that's used for quantizations, we can also calculate the level of quantization. L is equal to 2 raised to n. Same way, by using this number of bits that are used for quantizations, we can calculate the SNR. What is actually SNR? SNR is a signal to noise ratio. Okay, and for bit rate for the PCM is sampling rate into number of bits per sample. So they can be expressed mathematically is Fs into NB. Fs is the sampling rate and number of bits per sample is represented by NB. Okay, so these are all about this PCM, pulse code modulation, and at the reception. At the receptions, we have a PCM decoder. So, what are the PCM decoder components? We have a main component is the low pass filter. What is the procedure behind this PCM decoder is actually at the center side we are encoding the signal. At the receiver side we are reconstructing the original analog signal. Okay, so we have a digital signal, so it will be passed through this PCM decoder, and the main component is the low pass filter. By using this PCM decoder, what we get is an analog signal. You can see the output is an analog signal. Okay, so for PCM encoder, what is the input? Input is the analog signal, and what we are getting as the output is a digital signal. At the reception side, we have a PCM decoder. The main component of the PCM decoder is a low pass filter. So it takes the input as a digital signal and it produces analog signal. Okay, so we first പഠിച്ചിരിക്കുന്ന ടെക്നിക് PCM ആണ്. PCMന് സെൻറ്റർ സൈഡിലൊരു PCM എൻകോഡർ, അതുപോലെ റിസീവർ സൈഡിലൊരു PCM ഡീകോഡർ ആണുള്ളത്. സോ ഇറ്റ്സ് എ കോഡക് ടെക്നിക്, കോഡർ ഡീകോഡർ ടെക്നിക്കാണ്. സോ നമ്മൾ ഇൻപുട്ടായിട്ട് കൊടുക്കുന്നത് സെൻറ്റർ സൈഡിൽ അനലോഗ് സിഗ്നൽ, അതിനെ എന്തായിട്ട് കൺവേർട്ട് ചെയ്യണം? ഡിജിറ്റൽ സിഗ്നൽ, അനലോഗ് ഡാറ്റയെ ഡിജിറ്റൽ സിഗ്നലായിട്ട് കൺവേർട്ട് ചെയ്തു. റിസീവർ സൈഡിൽ ദിസ് ഡിജിറ്റൽ സിഗ്നലിനെ നമ്മൾ എന്തായിട്ട് മാറ്റുന്നു? അനലോഗ് ഡാറ്റയാക്കിയിട്ട് കൺവേർട്ട് ചെയ്യുക, അല്ലെങ്കിൽ അനലോഗ് സിഗ്നലാക്കി കൺവേർട്ട് ചെയ്യുക. അതാണ് ഇവിടെ നടക്കുന്ന പ്രൊസീജിയർ. ഓക്കെ, സോ എൻകോഡർ പാർട്ടിൽ നമുക്ക് 3 സ്റ്റെപ്പാണുള്ളത്. ഫസ്റ്റ് സാമ്പിളിംഗ്, ദെൻ ക്വാണ്ടൈസേഷൻ, ദെൻ എൻകോഡിംഗ്. ഓക്കെ, in PCM decoder the main component എന്ന് പറയുന്നത് low pass filter ആണ്. So these are all about pulse code modulation. Next we have another technique, that is delta modulation. So this is another variation or another technique that is used for analog to digital conversion. So by using some staircase function, here the analog input is approximated, or the analog input is encoding to a digital signal. Actually this staircase function is a function that can move up or down one level at each sample interval. It's a mathematical function, and here it has a binary behavior. That means we can, if the staircase functions go up, then that part is represented by binary 1, otherwise it is a 0. That means if the staircase function is an up value, then it is represented as a binary 1. If the staircase function has a down value, then it can be represented as a 0. Okay. So this is the basic technique that is used in delta modulation. Also, we have some features for this delta modulation. It improves the performance of PCM, or it reduces the complexity. Also, the basic logic is the feedback mechanism. Here, the staircase function is always changed in the direction of the input signal. So after the delta modulations, what we are getting as the output is binary sequences. Okay. At the receiver, they can be reconstructed into a original analog data. Okay. Also, this staircase function can be smoothed by integration process or by passing through a low pass filter, same as that in PCM. So, our next technique is delta modulation. So, delta modulation complexity koravana, better performance ulla oru technique aanu. Ivide nammal use cheyidirikkuna oru mathematical function staircase function annanu parayunnathu f of t ennu udeshikkunnathu. Appo adu staircase function go up aanengil adine nammal binary 1 aayittu represent cheyum allengil binary 0 aayittu represent cheyum. You can see in the figure we have an analog input. If that function is going upward, then this can be represented as a 1, otherwise it can be represented as a 0. Okay. So this is the delta modulation operation. First, we have an analog input. We are getting binary as the output. At the receptions, you have a binary input. Then what we are getting is a reconstructed waveform, that is the analog input. At the reception side, or at the transmission side, we have a comparator for producing binary output. Actually, comparator, what we are doing is we are comparing with the staircase function. At the reception side, we have a binary input, but we are producing an analog signal. Okay. So these are all about analog to digital conversion. There are two techniques. One is pulse code modulation and other one is delta modulation. Okay. I hope you are clear. Thank you.